Ecology is fieldwork. Introducing students to ecology is best done in the field, but it usually can only be an introduction. Conducting experiments in the field requires time, lots of time.
Yeah, make it look like science. Yeah.
For instance, in this tide pool, the students can see multiple organisms, both plants and animals. They can learn their names and handle them. But when it comes to asking scientific questions, time defeats the student who wishes to explore the answer himself or herself. What kind of question might be asked looking at the multiple organisms in a tide pool? How about a basic one? Why are the barnacles and mussels clustered like they are? Why aren't the filter-feeding non-motile animals as likely to be anywhere? One possible answer is that once a certain barnacle or mussel has claimed a site, another filter feeder can't grow there. This is the idea behind an ecological concept called competitive dominance. That is, filter-feeding animals compete for space in the tide pool, and some have an advantage over others or are dominant over others.
Okay. So you got this little mussel over here, and you can get all these little periwinkle there.
But how would you test that idea? You would have to mark an area of the tide pool, something scientists call a quadrant. Then you would note the position of each barnacle and mussel in the quadrant, and then make periodic trips back to the pool to check for changes. As you can imagine, any changes will take quite a bit of time, so checking back over 1 or 2 years may be required to get an answer to your question. It would be good if we could speed up time. That is what a computer simulation or model of a tide pool is for. Once the model is created using real, hard-earned information or data about competitive dominance in tide pools, an inquiring student could run the model to see how competitive dominance works. EcoBeaker, Maine Explorer, models a rocky intertidal zone, a scientific name for what we have been calling a tide pool. And middle school students can do an interesting experiment to see which is dominant over which. Nifty! But how do you get a computer to do that? Let's take a look under the hood at the engine that drives EcoBeaker, Maine Explorer. Behind the computer screen, EcoBeaker, Maine Explorer is made of computer code, specifically a computer language called C++. Here is what it looks like. Yikes is right. It is sort of English, but only sort of. Learning C++ might be as hard as learning ecology in the field, and would take you as long, too. But there is a shortcut that students in EcoScienceWorks are going to take so they can write models of ecology problems as interesting as EcoBeaker, Maine Explorer. It is called Star Logo The Next Generation, or TNG for short, and the programming is done by dragging and dropping the program's blocks into the programming space. You are watching them snap into place if the selected blocks will work together. Those colorful blocks are the elements of a programming language that can make things happen just like in EcoBeaker, Maine Explorer. When a program is completed, you flip the switch and your program is ready to go. We're going to meet some of the college students that are working on adapting Star Logo TNG for inclusion in EcoBeaker, Maine Explorer. We are at MIT's Teacher Education Program, where graduate and undergraduate college students work on programming projects intended for teachers and students in middle schools. It is an exciting place where ideas and interesting hard work gets done.
The first thing that got me interested in programming was seeing the computer games that my friends could program on their calculators just when I think it was the TI-82 had just come out. And everybody was programming games like the one where the snake goes around the screen, or Pitfall where you're falling down a pit, I guess. And that looked really interesting, so I wanted to learn that. And I asked my dad for a book about programming, and he gave me The Absolute Beginner's Guide to Programming by Greg Perry, I think. And I learned how to program in QBasic on the computer.
One of our motivations in the current version of Star Logo, though, with the blocks interface, has been to help people get over this barrier that they have to programming. Oftentimes people think that the difficult part of programming is remembering the words. remembering all the different things that they have to type in, the punctuation and all the other kinds of barriers that you may have seen in computer code, either if you do it yourself or seen it on the screen in a movie or something like that. And in fact, I think the hard part, and the good hard part, is actually remembering, is thinking about the ways that you're going to program, the ideas, the algorithms, the models behind it. That's the hard part, and that should be the hard part, and the other part should come easily. And that's why we've developed this blocks interface, to make it easy to do the part that people get stuck on, and to make the people be able to focus on the part that we think is really powerful for learning and powerful for creating new ideas. You can kind of think of it like writing a book. The hard part is not necessarily remembering all the words, but the hard part is actually thinking of the storyline and thinking of how it's going to go. And so we want people to be able to focus on the storyline and not have to focus on remembering all the words.
So, just to review, we had a whelk here. This stuff is like brown algae. It's kind of like a seaweed or stuff. We found a lot of these white tube worms. Okay, and they've got a calcium outer shell that the worm lives inside. Periwinkles are over here. And then these are whelk eggs.
Thanks for joining us. We hope that you have seen that ecology and technology can work together. For more information, contact the information on the screen.